Meet the world's most colossal helicopter, the Mi-26. Designed as a heavy-duty model, it's equipped with the power to hoist a main battle tank that weighs as much as 20 tons. So you can imagine how effortlessly it handles sizable trucks or large structures. What's even more remarkable is its capacity to lift an entire large aircraft, a testament to its astonishing load-bearing prowess. This twin-engine heavy transport marvel originates from Russia, specifically from the Moscow helicopter plant. Remarkably, the Mi-26 has maintained its leading edge in the global aviation industry for almost half a century, proving its mettle as a pivotal asset in Russia's arsenal. Let's embark on a journey to understand how this unparalleled leviathan of the skies comes to life. Being the titan it is, the Mi-26 necessitates a 5-member crew for operation. It's designed to carry an enormous weight of up to 20 tons. With a length stretching to 40 meters and a rotor diameter of more than 32 meters, this helicopter can cruise at top speeds of 300 kilometers per hour and climb as high as 6,500 meters. Our first stop is the electroplating workshop, where the Mi-26's skin comes into shape. The fabrication process of the world's largest helicopter starts from small sheets of a lightweight aluminum alloy. These sheets undergo anodic oxidation during electroplating, forming a light gray protective oxide film on the surface. This treatment enhances durability, boosts resistance to corrosion, and ensures an even oxide layer on the metal surface. Sulfuric acid is the key agent used in the entire electroplating tank. The aluminum alloy sheets are immersed in this solution where a strong electric current causes a chemical reaction between the metal and the acid, forming the protective oxide layer. The sheets, now ready after anodization, head to the helicopter body manufacturing unit. There, skilled workers cut them into the required sizes and methodically affix them to the helicopter's frame, using tens of thousands of rivets and bolts for a steadfast assembly. Rivets undeniably have a crucial role in the construction of the Mi-26. Each helicopter demands the use of over 50,000 rivets, demonstrating their integral part in aircraft manufacturing. Originally, the former Soviet Mil Design Bureau was behind the design and manufacturing of the Russian factory, tasked with the production of this behemoth of a helicopter. Innovation was the name of the game, with the introduction of advanced materials playing a critical role in the project's success. The need for materials that were both lightweight and durable was a given, but the real test came in molding these materials into complex geometric shapes. Accuracy was everything, with a razor-thin margin of error measured in micrometers. This is where the lathes produced by the Japanese company, Mazak Corporation, came into play, providing the precision needed for the Mi-26's machine tooling. The production process, taking place in the Mi-26's body manufacturing workshop, could be likened to an intricate jigsaw puzzle. Precision-crafted parts are joined together piece by piece, resulting in a completed component assembly. Once the body is fully assembled, engineers go to work connecting the cockpit to the fuselage. Using titanium alloy bolts and rivets, they ensure every component is securely fastened. Crafted from a robust yet lightweight aluminum alloy, the body of the helicopter manages to keep the total weight down to a mere 29 tons, even though it can haul around 10 tons of fuel. Considering the enormous size and heft of this helicopter, it's no surprise that an equally powerful propulsion system is required. The turbine engines, a product of the Ukrainian Zaporozhye Machine Building Design Bureau, each churn out an astonishing 11,500 horsepower, and it takes not one, but two of these engines to power each Mi-26 helicopter. The design intricacies don't stop there. The helicopter is equipped with 8 rotor blades, each spanning over 15 meters in length. Made from lightweight composite materials, these blades are more reliable than their metal counterparts, offering higher corrosion resistance, greater strength, lighter weight, superior compressive resistance, and enhanced flexibility. The core of each blade is made from a titanium alloy, prized for its exceptional hardness and often used in the most demanding parts of aircraft, like landing gears. These blade cores are polished with a gemstone grinder to ensure a flawless surface, free from any cracks. Over on another side of the manufacturing plant, we find the intricate process of producing the composite materials for the rotor blades. The blades are filled with a honeycomb-like composite material the production of which is no simple feat. First, engineers apply a layer of epoxy resin on the paper-thin composite material sheets. These sheets are then placed in a specialized oven for high-temperature baking and hardening. Once hardened, the composite material surfaces are ground and polished before being assembled around the blade core. Just 26 pieces of this lightweight composite material are needed for each blade. As the world's largest helicopter production facility, the plant spans 300,000 square meters and employs more than 3,200 workers. At this point, the body of the Mi-26 helicopter has been fully assembled. Next up is the integration of the cockpit. The assembly process is pretty straightforward. Once the precise installation position is aligned, thousands of bolts and rivets are used to securely fasten the cockpit. Following this, the engine cover housing the propellers and the two turbine engines underneath it are installed. Finally, all control cables and tens of thousands of signal transmission media are connected to the dashboard. After these cables are successfully gathered at the dashboard, a long process of fine-tuning begins. Electronic engineers need to ensure that all control cable signals can be received and transmitted perfectly. This requires not only exceptional talent and intuition on the part of the engineers, but also accurate judgment concerning the electronics. The kilometers of cabling serve as a giant nervous system for the helicopter, complete with a complex dashboard control system and tens of thousands of semiconductor electronic devices. Even the smallest undetected error could potentially lead to catastrophic consequences for the helicopter. The black part of the Mi-26 helicopter's cockpit is the only component not made from lightweight aluminum alloy. It houses the meteorological radar transmitter antenna, with the exterior grid known as the radar dome. This radar dome has a range exceeding 300 kilometers. The surface of the dome is colored black, a design choice intended to prevent surface reflections from interfering with the pilot's operation. Once all installation and adjustments are completed, a fully assembled Mi-26 helicopter is born. The next step involves a series of complex tests to check for any performance issues under real-world conditions. Before testing, the team places 4 2.5-ton iron weights inside the helicopter's body, then launches it into the air to carry out a variety of complex maneuvers, like 360-degree rotations, forward and backward movements, trailing flight, and low-altitude flying. Only after the Mi-26 heavy-duty helicopter passes these tests without issues is it ready to be handed over to its new owner. That concludes the journey through the production process of the world's largest helicopter, the Mi-26. Thanks for joining us and for your support. If you're interested in more videos like this, feel free to subscribe to our channel. We'll see you in the next episode.